Okay.
Look at my fingers.
All right, guys.
I need to see the room.
Welcome back. Everybody. Hey. Everyone.
My name is Jeff.
All of you. Shut up. I don't know what the hell to do. So remember this. And compare it to, we're about to get into hypothesis tests for percentages. So the weird part about that problem is, how the hell do I make a z-score out of a percentage? I know how to make a z-score out of an x. But how do I make a z-score out of a p? Right, that's what we've got to piece together. Oh, I love the look. So compare that formula to this formula. What is acting like the standard deviation here compared to where the standard deviation is here? So here's the standard deviation in this thing, right? So for NPQ problems, it looks like the standard deviation should be that. And to be honest, what I just said is sort of backwards. We actually start here and kind of undo it for the other stuff. But we don't teach it the way we discovered it. We teach it the way that makes more sense. But now I can see, comparing these two things, that must be the spread for NPQ kind of problems. Now tell me, when do I use S? Only when I don't know sigma. So when do I use sample information? When I do not know the population information. So when do I use P hat, Q hat? When I don't know
P and Q.
if P and Q are not known. But remember, what is it in a hypothesis test? What starts us off? Assuming you're right. We assume that the thing in the claim is the population thing. And then I see if it leads to a contradiction or not. We do the same thing when I have a claim about a percentage. So we're going to assume, if I say, I think the percentage of students passing stats is 66%, that would be P. So I'm not going to use frickin' P hat and Q hat, because I know P, and if I know P, I know Q. So the formula for the z-score, you're going to love this, for a hypothesis test about a percentage, the z-star formula will be this. It'll be the sample information. So that'll be P hat. That's what I get from my sample. Is that cool? That's just like X bar. P hat. That's what I get from my sample. Minus P, the value from the claim, divided by the standard deviation. Do these have hats? Hell no. Because I know P and Q now. I'm assuming I do. So don't freak out. We will do a problem real quick. And then I have another handout. Oh, shit. So I'll tell you, I have a handout with two problems. So instead of me making a problem and having you do these two, we'll do the front one, and you guys can do the back one. So we'll do the front one of this right now, and you guys can do the back. What is there already? Also, there's yes.
P is the p-value or what?
Hell no.
Percentage.
When we mean p-value, we got to say p-value. If I just say p, that means probability of success. Everybody with me? I can't have a p-value in my claim because I have to have done the test to even figure out the p-value. I can't start it off with a p-value. So this is step 4, of course, right? Or step D. So that's one change. Who remembers what you got to check to see if it's normal enough in an NPQ problem?
P times N times
Yeah, NP and NQ.
Greater than 5, greater
They
than
have
equal
to be at
to.
least 5. I like it. So that's two little differences, or one of them's little. Instead of n greater than 30, you can't say that shit anymore. With an NPQ problem, you got to check these two. We know that. You guys especially know it after that quiz. So I think 98% of you missed that question. So if you missed it, don't feel like you're alone. And this is the big change. But it's still the same z-score formula. My data minus the supposed middle divided by the spread. That never changes, ever. Okay, so let me give you this. We'll do this one together. We'll do number 1 together. Say again?
What?
Exactly. Depending on
No,
what
not yet.
our data
Huh?
looks like, what the
Yeah.
real middle looks
Says
like,
10.
what the spread looks like. Same idea is
No,
right there.
this is all 10. This is chapter 10.
No, this is not chapter 10.
Yeah.
This is part of chapter 9.
Well, okay.
Chapter
Then why
10
could I
is we
do
have
it?
2 samples.
Oh.
This is just with percentages.
Oh.
Yeah.
Oh, that's easy.
This is all chapter 9 with percentages. Chapter 10 is what we have
This is still chapter 9. It's just one sample. Chapter 10 is
Killing
samples.
us. Smack me.
All right, let's try out problem number 1.
If I don't get these right, I swear, I'm done. You think I'm joking? I'm gonna get out here and leave. If it's not right.
All right, let's see.
Thanks.
It's not Munis. It's not Munis.
Alright, I'm out.
I don't know if you guys
Well, is
remember
everything else
Occupy
right?
Wall Street.
I don't know.
We still talk about the 1%. For example, I think 84% of tax cuts went to the 1%. I can't remember the most recent story. Oh well.
Here.
Yeah, if you're
That's what I
born
heard, bro.
into it,
That's what I
you're set. If you're not,
You're screwed.
too bad for us.
Too bad for you.
This means you have to work, which makes life better, to be honest. We feel that at least 20% of Americans oppose the Occupy Wall Street movement at its height. A random sample of that many showed that many, blah, blah, blah. So what is the claim?
P is greater than or equal to.
P is at least a greater than or equal to. What's up?
No, never mind. I was congratulating myself.
Finish that statement for me.
0.20.
0.2. 0.20 even if you want. I like it.
I'm not leaving.
So which one is that going to be, the ho or the high?
Oh.
It's got an equal sign in it. So what's the high going to be?
Less than.
Yeah, because the test is a test about a percentage, right? Yeah. In fact, later this semester, like later this week, we'll be having, we'll learn the way that we can do sigma there. You can do tests about means, about mu's, you can do tests about percentages, p's, and you can do tests about sigma. Yeah. Oh shit. So here this is definitely a percentage. What's the high again, sorry?
Less than. 0.2.
Yeah, so you can put 0.20 if you want. Cool. I like it. Yes, ma'am.
So for the claim and the hoe, they're both the same?
No.
Press equal sign or less than?
So the way you said it had me worried. Whatever the claim is, if it's an equal sign, it will go in for the high. If there is no equal sign, it will go in for the high. So greater than or equal to, there's an equal sign there. That's why it's the high. That's it. That's it. The claim could be either one. That's why we word our conclusion based on which one the claim is, because it could be either one. So again, real quick, since we feel this way, do we want the test to succeed? Do we want to reject the null? No. But the test doesn't give a shit what we think. It's going to try to reject the null, and we're sort of going, I hope it doesn't, because that's how we feel. I don't want to say I'm wrong. Okay. So it's a one or a two-tail test?
One.
Totally one tail. In fact, what size?
Left.
Good. Got it. Now, sometimes I'm nice with this. Do you notice how I asked this question? Can we use z-scores? What's missing?
T.
T. You never use T with an NPQ problem. Why? Because we make sigma. Now, some people look at this problem and are like, I can't do shit because I don't know any standard deviation. You don't have to be given one. We make it. Don't we? There it is, right? We make it based on what P and Q and N are. So we always know it. The real problem is, what do I check here? We got to check to see if NP and NQ are bigger than or equal to 5. Right? So what's NP? What's N? 996, the total number always, not that 183 little puny thing. 996 times what's P? Good. 0.2. Not P hat. P. And what is 996 times 0.2? What is it, 189? 199? 0.2? Okay, that's at least 5. And Q is 996 times 0.8. That's definitely going to be at least 5.
I'll let y'all do the math for
You
me.
guys want to pay attention probably. What do you get?
736.
Okay, that makes sense. At least 5. Check. What does that mean?
We're good.
What's it mean better than that? More specific.
Normal.
Normally enough. I like it. It sounds like, yeah, normal enough. Go on now. Yeah. Well, if P is 0.2, Q has to be 0.8. Second? Normal enough for what? To use the z-score chart and all that kind of stuff. Yeah. Yes?
Why is the area in one tail?
Why is it one tail?
Yeah.
So this is the guy that we can show evidence for. So it's always going to be the part that thinks it's extreme, one way or the other or both ways. So that always sets up, the high always sets up my rejection region. And since I only want to show that it's less than in this case, I only have one tail. I like it. The claim does not set up my rejection region. The high does. So how do I show that the hoe is wrong? I have to show a sample that is really far below 0.2. That's the way I show somebody's wrong who thinks it's at least 0.2. I got to show something so far below 0.2 they must be wrong. Okay, maybe we stop. Okay. Yes.
Why would you even check an NQ cap?
I don't need to. That's less specific. P hat is an estimate for P. Do I know what P is? Yeah, I'm assuming it's 0.2. That's why we don't use any P hats and Q hats until it's time to compare mine
93.
against that. That's the only place that P hat shows up, at one place. Yes, normal enough. We can use z-scores. Yes. Say again? Yes. To answer the question, can we use z-scores? Yes. Why? Because of this. I love you guys. Alright, so we can use z-scores. It's a one-channel test. Alpha is what? 0.05. Take a minute, don't say anything out loud yet. Look up the rejection region z-score. One tail, 0.05. All the way to the bottom you get
1.965.
1.645.
And we put a negative on it because we're the humans. We're a little bit better than a piece of paper.
We can use a Z-chart or a Z-chart,
No.
right?
I somebody in the back was like, I gotta stop lying, I'm not you. We can't deal with that right now. You're a lizard shapeshifter.
Is the middle point 2 or no?
Say again?
The middle?
Alright, so again, what is the middle officially? What kind of picture is this? This is a picture of z-score, so what is the middle? Zero. Now, in terms of percentages, the middle is 0.2. You can kind of, 0.2 there if you want to. But that doesn't really come into play. We're comparing z-scores to z-scores. Okay. How do I say this in words? If z-star is
Less than
less than,
a negative.
we can do what?
Reject.
Reject the low, support the high. Taxes off. Okay. And now it's super nice on this one. Geez, look at that. And tax check. So we know N is 996. We know X, the number of successes is what? 183. So 183 out of 996 gives me a p hat of
1837. 1837.
ooh, 0.1837. You could point 1837. Yeah. Okay. You could say 0.184 officially, but showing 4 places is even a little better. I love it.
I could end it better by X.
Is that cool? I'm a little concerned about the number of people that cannot get a percentage from a statement about a sample. It's always the part divided by the whole. That's what a percentage is. That's what it is primarily, fundamentally. It's part divided by whole. That's what a percentage is.
Is this a valid
Yeah, totally. What do you mean? On a formula sheet or something? No.
No.
When you're going to write it on, yes, that's exactly how you say this in words.
But then on here,
Yes, totally. Totally.
We failed.
Okay,
That's what I got.
so what goes here?
0.1837.
Yeah, that's our data. 0.1837 minus the middle that we assume to be
0.20.
0.2. Divided by the square root.
0.2.
0.2 times 0.8 divided by
Square root of 996.
996. Oh shit. Now this is where you can really get a lot of interesting calculator errors. The best way to do any of these problems is to put the whole damn thing at once. So if you do 0.1837 minus 0.2 in parenthesis divided by the square root 0.2 times 0.8 over 996. You don't have to round anything off. That's going to be it. If you have the older one that has a parenthesis in the square root, just don't close it until you get all that stuff in there.
So we don't have to show word with these. Because in the past you said show word.
Totally. This is your work. I don't need you to do this piece by piece. It doesn't do anything for me unless you were in Math 88. You're a little beyond. So this is, I know it can get confusing. It shouldn't. All right. So this is your work on this problem. This. Now that's a bunch of shit you throw in the calculator. You know how to multiply and divide and all that crap. So you get, I get negative 1.29. Neither. Let me see. Yeah. Do we have an older one?
I got the same one.
Oh, yeah, what's your 6?
I got 286.
All right. Everybody give this old
I should've
grandpa
had.
a break.
I'm afraid of
Not,
it.
not backlit.
Because you know that, you're good.
Yeah. I always go more or less and I get in trouble for
Oh,
it.
see, that's not an old one.
Oh, I can see.
What? Does your square root grow?
No. Mine
Okay.
doesn't.
Here we go. 0.1837 minus 0.2 divided by square root. There we go. There's an old one.
I can't even
Oh.
see. Oh, there
I
we go.
know. I'm trying to get there. See this parenthesis that opens?
That's how mine is. I'm an oldie.
0.29. Just don't close the parenthesis until you're done with everything that's supposed to be in the square root.
Yeah, I got the right answer.
And I still get negative 1.29.
I think she forgot to put the divide.
You see it?
I'm a dumbass.
Now, guys, there's P's with hats on it, and there's P's, and there's freaking p-value. Oh shit! But what's the p-value? It's
0.2.
the area of my z-star tail. That's the quick way to say it. So where we get negative 1.29 is like right here, maybe.
We failed.
What's the p-value? It's going to be the area in that tail. The chart tells me areas below, so I'm not going to have to do anything to it when I look it up, because it's going to do what I want. It's only when it's the tail on the other side I got to adjust it. So when you look at negative 1.29, what do you get? Because they always round to two places, and it was 1286, if I remember correctly. What's happening?
0.0985.
Oh, because you got so many parentheses. Look.
Well, obvious.
There's not enough.
Do it again.
So the whole top has to be in a parenthesis there. Open, open, close, close.
So what is 0.0985 versus z-score?
Yeah, that's one thing. Let's see.
Oh, we're working backwards? This is a
The whole
z-score
top
right
has
here.
to be in parentheses. All right, what do you guys get for the p-value? 0.985.
Yeah. Oh, it's a p-value?
What's the matter?
Is that a p-value or a z-score?
I don't know. I don't have any more z-score charts. So
It's a z-score.
when you look at 1.29 negative,
Yeah.
you get 0.0985.
So it'd be a z-score.
No, hell no.
Oh.
Where is it? When I look up a z-score, I of course get the area in the tail. That's the p-value. P-value is the area in the tail. So that's roughly the chances that what we got was due to random. That's almost 10% chance. That's like not unusual. Like, I'm okay with that. I mean, it's not enough evidence. You guys understand? It was below. But in order to be enough evidence, it's got to be compelling evidence. And a 10% chance that it just happened randomly and the mean is in the right place, that's too big of a chance. It's not good enough evidence. Enough evidence would have been a z-star below negative 1.645. A p-value below, what was it, 0.05? Yeah. So this probability is too big. Do you need this to even answer this? Not really. You just need it to answer that piece. But what's the answer to the hypothesis test? That did not make it far enough away. So do we reject the null? No, it failed. We didn't make far enough away. Failed to reject. So that means I failed to support the high. Which one was my claim?
The hoe.
The hot, the hoe. Claim is this. That's my claim right there. So then I use this language. Fail becomes we have not found sufficient evidence to reject the claim that what?
At least 20% of Americans oppose the Occupy Wall Street movement.
Yeah, and you can just steal it from there. At least 20% of Americans opposed OWS. Sounds like a test in Harry Potter, that's it. We have not found sufficient evidence to reject the claim that at least 20% of Americans opposed OWS. And if that's our claim, this is a good result for us. We didn't reject it. All right. You guys do the other side.
That's funny. I have no idea.
That problem relates to you guys.
Alright.
How is that further below zero?
Is it equals equals not equals?
It's a true number line, so. And that's why I ask you to do it in words also, so you can always just compare it to that instead.
Yes,